Our next speaker and our last speaker is Paula Albendea. She's a student at the University of Barcelona in Spain and will be speaking about effective feeding olive pomace acid oil on the lipid composition and oxidative stability of chicken and pork meat. Paula?
Hello to everyone. I would like to start this presentation with a short background. So, for meat industry, it is really important to reduce cost, but also it is mandatory to guarantee the meat quality. One of the ways to reduce cost is searching for alternative fat sources in animal feeding. This is the case of acid oils, which are fat byproducts coming from edible oil refining with similar fatty acid composition to the crude oil. So, the aim of this work was to answer the next question. Has the inclusion of olive pomace oil, which is the crude oil, and olive pomace acid oil, which is the fat byproduct, in feeds any significant effects on lipid composition and oxidative stability of chicken meat and pork? To answer this question, we performed two different studies, one of them in pigs and the other one in chicken. In both cases, we used 3 dietary treatments, one of them with crude palm oil, other one with crude olive pomace oil, and the last one with olive pomace acid oil. The type of meat samples taken in the case of chickens were legs with skin, and in the case of pigs were loin. We performed the analysis in fresh and also in refrigerated samples. And the parameters we consider in lipid composition were fatty acid composition and tocopherol and tocotrienol content, which as vitamin E compounds have antioxidant properties. And for oxidative stability evaluation, we performed thiobarbiturate acid values determination. Here in this graph, we can see the fatty acid composition results. We observe significant difference among the dietary treatments in chicken meat and in pork. This is in concordance with the fat used in each case. For example, the palm has the highest saturated fatty acid percentage in both types of meat. Here in this table, we can see the tocopherol and tocotrienol total content. We also found significant difference among the dietary treatments in chicken meat and in pork. Under refrigeration storage reduced the tocopherol and tocotrienol total content in the case of olive pomace acid oil in porks, as we can see here in this part of the table. To finish with the results, here in this graph, we have the thiobarbiturate acid values represented as malonyl concentration, which is the main secondary oxidation product. We found significant difference among the dietary treatments in all cases, being olive pomace acid oil the one with the highest TBA values. The refrigeration increased the TBA levels in both types of meat. So the answer to our question is yes, the inclusion of olive pomace oil and olive pomace acid oil has a significant effect in lipid composition and oxidative stability in chicken meat and in pork. So the inclusion, the use of these two fats allows us to produce meats with lower content of saturated fatty acids. Based on the oxidation results, we will say that in the case of pork, it will be preferable to use olive pomace oil instead of olive pomace acid oil. But in the case of chicken, we could use both types of fat indistinctly. So thank you all for your attention.
Thank you, Paula. I enjoyed your presentation. It was very interesting. Of course, olive pomace oil is a undervalued material, especially the acid oil. So I'm very pleased to see this being successfully applied in animal diets. There's a question here about the animals' preferences for the feed. Did you notice were you part of feeding the animals, or did you just get the meat and analyze that, or what was your role?
Well, here, these two studies, we collaborate with one company, which is Bonaria. So we didn't feed the animals.
It's a strange thing with animals because they seem to like things that we don't like. So I was curious to see about that. Do our judges have some questions?
Well, I have a question.
Yeah,
go ahead.
Okay, I'll go ahead then. So what was or can you explain the differences that you observed in the levels of oxidation? What was the mechanism behind that, do you think?
Well, we have to perform more studies in oxidation stability because we use also a ferrous oxidation Silenol method. So I think that maybe the conclusions we are going to get them after this type of analysis. Also, we are going to analyze the volatile compounds. But here, I think that the most important thing is that in the case of chicken, we have lower levels of oxidation than in the case of pork. But this could be due to maybe to a lower tocopherol content, or maybe because other things that we have to study.
Okay, thank you.
Yeah, question. In the refrigerated pork, the olive pomace performed noticeably better in terms of oxidation stability compared to the OPA, but they had a similar fatty acid profile. What do you think is causing the better performance of the olive pomace compared to the OPA? Is it the tocopherol content, or is it something else?
Well, it could be the tocopherol and tocotrienol content, because in the case of olive pomace acid oil, we can see that the tocopherol and tocotrienol in the meat was lower in this dietary treatment. But also, maybe when we perform this analysis, the same I have just said, maybe we could reach to more conclusions.
Thank you.
All right.
Thanks.
Thank you, Paula. I have a question about the OP and OPA. It seems in chicken, no matter fresh or refrigerated, compared to OP, OPA significantly increased the tocopherols and the tocotrienols concentration, but in pork, it's opposite. So what is driving this difference?
Yes, well, one of the important things of the acid oils is one of the drawbacks is the variability in the composition of between two batches from the same olive, from the same byproduct with the same process. So maybe this difference could be due to this composition.
Composition of OP and OPA?
Yes, between chicken, because the first idea in this study was to perform the two studies with the same batch of fats, but due to technical problems, we couldn't do this. So we have to perform with different batches. So maybe the chemical composition of olive pomace acid oil in the case of chicken is different to the olive pomace acid oil in the case of pork.
All right, thank you. So you have the fatty acids composition of the chicken and the fat. Do you also have analysis data to show the difference between OP and OPA?
Yes, yes. The thing here in the poster and in the presentation, I only saw I only put in the fatty acid composition of the meat, but we also analyze the fat and the feed. And the difference could be in some parameters as moisture, impurities, and unsaponifiable content. So maybe it's not in the fatty acid composition, but it's in the relation between pro-oxidant and antioxidant. of the
Okay.
fat.
Understandable. You have only limited space to put selected data onto it. So is it possible, like maybe by memory, what is the biggest difference, chemical composition difference between OP and OPA?
Well, I think that in the case of chicken meat, we are talking about moisture impurity and unsaponifiable quantity, the total of 6% in the case of chicken, and in the case of pork, we are talking about 12%, more or less. I don't remember exactly, but more or less, these are the quantities.
All right. Thank you, Paula.
Thank you.